In fiber optic networks, power alone doesn't guarantee performance. Instead, it's just as important how clean the signal arrives at the receiver. And this is where the optical signal-to-noise ratio, or short OSNR, comes into play. If you want to find out more, stick around and we'll check it out. Optical signal-to-noise ratio is optical signal power in relation to optical noise power. What does that mean? Well, let's for argument's sake say my voice is a signal and the ambient noise here, well, that's the noise. And at the moment you can understand me really clearly because the ratio between my voice signal and the noise signal is really high. So we've got a high signal to noise ratio. But now, for example, the noise level is much higher. So in other words, we've got a lower signal to noise ratio. In both cases, the level of my voice, so the power of my voice, was exactly the same. But with the lower signal to noise ratio, it was more difficult for you to understand what I was saying. And that's the same for optical transmissions. Because the signal power itself, well, that's not enough. We also need the good signal to noise ratio for the receiver to be able to understand what it is actually receiving. And that directly translates to the bit error rate, because if we have a higher OSNR, well then we have a lower bit error rate, and whereas if we have a lower OSNR, well, in that case we have a higher bit error rate. Now, of course, the longer the distance is that we're going and the higher the data rate, well, the better the OSNR actually has to be. Now, there's another interesting thing about OSNR measurement, and that is you can actually use it as an indicator to see equipment deterioration. How does that work? Well, to understand how that works, we first need to have a look at what actually is introducing the noise into the transmission. And there are many contributors. So we've got the nonlinear fiber effects, filtering and narrow ROADM passbands, fiber attenuation, transceiver noise, you name it. But the one that's actually right at the top of these contributors is optical amplification, especially when we're talking about longer transmissions. And to be more precise, it's actually the EDFAs, so the erbium doped fiber amplifiers. And why is that? Well, the EDFAs, they use stimulated emission to amplify the signal, but whilst doing that, we also have the spontaneously emitted photons from the erbium atoms. And these spontaneously emitted photons, they actually result in a wideband noise, and which is also referred to as ASE, so amplified spontaneous emissions. If you want, I can go into more detail on the ASE in a different brain snack video. Just let me know in the comments. So how does this help us detect deterioration of equipment? Well, let's have a look at what happens with an EDFA when it's starting to age. And there are various things that are happening. So we've got the pump lasers that start to deteriorate, and the erbium ions, they start to age as well, which is a reduced stimulated emission efficiency. And we've also got the increased fiber absorption in the erbium doped fiber coil. Now, all of these, among others, all contribute to a higher ASE level, meaning the output of the EDFA has a lower OSNR. So, in other words, if the OSNR of an optical transmission starts to get worse over time, well, the chances are that that maybe is due to the EDFA deteriorating. So, how do we measure OSNR? Well, OSNR is usually measured in the optical spectrum domain, and that's why we use optical spectrum analyzers to do so. And it looks a bit like this. So here on the left-hand side, we've got a signal which is a short distance and is unamplified. And as you can see, this is the signal here, and down here is the noise, and we've got a nice big delta between the signal peak and the noise. However, here we've got the same signal but going over a long fiber distance and being amplified, and you can see the noise level is much higher, and then ultimately the delta between the signal peak and the noise level is much lower. So I hope you learned something today and that you enjoyed this video. If so, please leave a comment. And of course, remember to follow our channel so you get your regular dose of brain snack. Until next time, bye bye!